Hello everyone. In this presentation, we are going to understand how to interface a servo motor with TIVA microcontroller. As we all know, TIVA microcontroller is a controller which contains ARM Cortex M4 inside, which is useful for so many control applications as well as signal processing applications. Here we are going to experiment how a TIVA microcontroller is helpful in controlling the servo motor, means controlling the position of a servo motor. So here, as we all know, TIVA C series launchpad is most familiar. So this is the TIVA microcontroller and this is the TIVA C series launchpad, which is very much helpful for us in interfacing the servo motor. So here you can see the servo motor, which is changing its angle from 0 degree to 180 degree and then 180 degree to 0 degree. So this position control can be done with the help of change in pulse width modulation, as you see here. So when you look at it here, when the width is minimum, so it is in 180 degree. When the width is in maximum, it is in the 0 degree. So the change in position of the servo motor is inversely proportional to the width of the pulse. So when width increases, it comes back to 0 degree. When width decreases, it comes back to 180 degree. So with this minimum, it is in 180 degree. With this maximum, it is in 0 degree. So by changing the width of the pulse, we can able to change the angle of this servo motor as we see here. So if it is a servo motor, you can vary the angle. If it is an LED, if you see, you can vary the intensity. Here if you look at the red LED here, you can able to see the intensity variation. So when width increases, intensity increases. When width decreases, intensity decreases. You can see the intensity variation. Okay, so if you look at the block diagram of this, you can see, so the TIVA C series launchpad, in this there are 3 pins. One is 5 volt power supply must be given to the servo motor, and the ground has to be given to the servo motor, and we have to give the PWM signal from the microcontroller, which is taken from the 30th pin of the launchpad, which is nothing but your TIVA microcontroller's port F's first pin. Okay, so this is the circuit schematic of the servo motor interface, and when you look at the block diagram of this, and this is the block diagram where TIVA microcontroller is interfaced with the servo motor. Okay, so this 30th pin, this PF1, is the PWM pin. How do you understand? Means we can understand from the schematic of the TIVA C series that we can experiment in the laptop screen. So now if we go to the laptop screen, so there is an Energia tool, as we all know, to work with TIVA microcontroller. That there is a tool directly from the Texas Instrument is an Energia tool. From this Energia tool, we are able to look at the pin diagram. So in this website, you are able to see the pin diagram. Here you can see the red LED. So we can able to see the brightness of the changing, which is red LED. Red LED is connected to 30th pin. This 30th pin is PF1. So the port F1's alternate function is pulse width modulation, that we need to understand. Port F function's alternate function is pulse width modulation. Hence we are connecting the 30th pin to servo motor's output. That means servo motor's PWM input. So for example, what is 30th pin? The jumper 3's 30th pin is here. It's the bottom left corner here. This is our PWM signal. If you see, this is our PWM signal, which is the 30th pin. We are taken out and then given to the input to the servo motor. And there is a supply voltage and ground. So this is the, if you look at in the top right corner, here you are able to see the ground pin, which is 20th pin. You are able to see the ground pin, which is 20th pin. And this is the ground pin, which is taken out and then given to the oscilloscope ground as well as servo motor ground. And then if you see the 5 volt power supply, if you see 5 volt power supply is the 21st pin with respect to this. So 21st pin, you have taken the 5 volt power supply and then given to the servo motor. So 5 volt ground and PWM pin is more than sufficient to drive a servo motor, as we are seeing right now. So now if you look at the coding part, it is very simple. So this is in the Energia. We have a sweep. There is an example program called a sweep program. If you go to this file, If you go to this examples in the Energia, here in this examples, if you scroll down and if you see there is a servo application available. In this servo application there is one option called sweep. If you select this sweep, this code will come. So here we are including the header file from the library, which is servo.h is the header file which we are including, and the variable is my servo is our variable, and we are keeping the initial position as 0. And as we all know, setup is nothing but something like void main, where we are initializing the my servo function, that is attached function to PF1, where PF1 is the PWM generation from the TIVA microcontroller, as we all know. And then in the loop, starting from position 0 to 180 degree. So from 0 to 180 degree, with a step angle of 1 by 1, we are able to put. So POS is 0 first, then POS is 1, then POS is 2, POS is 3, up to 180. The for loop will continue with the delay of 15. So my servo write means you are writing the position value to the servo motor. This is the syntax. So which will be connected to the my servo is connected to PF1, as you see PF1. PF1 is the PWM signal of the TIVA microcontroller. So 0 to 180 degree, which is step angle of 1 with a 15 millisecond delay, it goes from 0 to 180 degree. After this for loop is over, it comes back to the next for loop, where from the 180 degree angle to 0 degree, it decrements 1 by 1 with a delay of 15 millisecond. So this loop continues. So 0 to 180 degree with a delay of 15 millisecond. 180 degree to 0 degree with a delay of 15 millisecond. So this loop continues. So servo motor will turn from 0 to 180 degree and then back from 180 degree to 0, as we see here right now. So here you see 0 degree to 180 degree. So 180 degree to 0 degree. So we can able to see the pulse width also varying accordingly, as we see here. So if you closely look at it and see, when the pulse width decreases, it increases. When pulse width increases, it decreases. So this is how we can interface a servo motor with TIVA microcontroller. This is one of the application, which is sweep application, which we have experimented. Thank you.